Hello everyone, I am Suraj and here is the question of the day. So the question for today is the maximum candies allocated to K children. In this question, we are given an array candies and each element in the array denotes a pile of candies. Okay, and we need to allocate those candies to K children and each children can be allocated candies from only one pile. And at last, we need to return the maximum number of candies each child can get. Okay, so let's understand the question first. So in this question, we are given an integer k which denotes the number of children and an array of piles of candies. Okay. So the first solution you might be thinking is simply what we can do. We will just add all the candies in all the piles and at last just divide it by the number of children. So it will give me 5 plus 8, 13, 13 plus 6, 19, 19 divided by 3 is 6. So can we give 6 candies to each children in this question? The answer is no. Why so? Because if I want to give 6 candies to each children, what I need to do, first of all, I will take 6 candies from the last one. Let's say I'm taking 6 candies from the last one. Okay. Now I will take 6 candies from this 8. I am taking 6 candies from this and 2 is remaining. Now I will take 4 candies from the zeroth index. I am taking the 4 and that's how I can give the 6 candies to each children, but this is not allowed in this question. Why so? Because it is written that each child can be allocated candies from one pile only. And in the last, when I'm allocating the candies to the last children, I am taking the candies from two piles. I took these two candies from the first index and these four candies from the zeroth index. And that is why it is violating the rule of the question. So that is why 6 cannot be our possible solution. So let's see if 5 candies can be given or not. So if I want to give the 5 candies from the first index, I can take 5 candies and 0 is remainder. From the first index, I can take 5 candies, 3 will be the remainder. From the second index, I can take 5 candies and 1 will be the remainder. So it is not violating any of the rule of the question and that is why 5 will be our answer. So let's see first of all the constraints. So in this question, the candy's length is 10 is per 5. It means the value of n can be raised to 10 is per 5 at max, 10 raised to power 5. So that's why in this solution we cannot use the n square approach. Why so? Because if we will go square to n square, then it will reach to 10 raised to power 10 and that is not allowed because at max whenever we are making a solution at max we can go to 10 raised to power 8 only. That is why the n square approach is not allowed here. If we will go, we will get TLE at the last. So what and how I'm gonna solve this question? So first of all, I will break this question into two parts. First one will be I will predict a value and second I will check whether it is a possible possible solution or not. First of all, I will predict a value and secondly I will see whether it is a possible solution or not. First of all, I will be focusing on this second step to how we will be checking whether it is a possible solution or not. Let's do one thing. First of all, let's take the value to be 6 and see whether it can be a possible solution for us or not. So what is my array? My array is 5, 8 and 6. And let's see, first of all, I will be checking the first index that is 5 and the predictor value is 60. Okay. So is my 5 greater than or equal to 6? No. So I cannot proceed with it. I cannot proceed with it. Now let's see the 8. Is my 8 greater than or equal to 6? Yes, it is greater than 6. So I will just decrement 6 from it, and I will take one variable, number of students, initially with 0, and I know that I decremented 6 from it, so I will just increment it by 1. Now my 8 has become 2. So is 2 greater than or equal to 6? No, so I cannot move further with it. Now let's next index is 6. So is 6 greater than or equal to 6? Yes, it is. So I will just decrement it and increment my number of children's by 1. So it will be 2 now. Now my value of at this index will be 0. So is 0 greater than or equal to 6? No. So I will just stop and see what is the value of my number of children, that is number of children's. So that is 2. So is 2 greater than or equal to k? No, it is not. That is why 6 cannot be my possible solution. I will take one more example to make it clear. Let's do it again. My number of children is 0. In this time, I will be taking the value to be 2. Okay. Now again, it was 5, 8, and 6. First of all, I will be taking 5. Is 5 greater than or equal to 2? Yes, it is. So what I will do, I will decrement 2 from 5, remaining is 3, and increment this by 1. Now is 3 greater than or equal to 2? Yes, it is. So I will decrement 2 from it, and now it is 1, and again increment the value of NC. Now is 1 greater than or equal to 2? No, it is not. So I will move to the next index, that is 8. Now, is 8 greater than or equal to 2? Yes, it is. So I will decrement 2 from it, and it will become 6. And as I have decremented, so I will just increment the value of NC to 3. Now, as I know 6 is greater than or equal to 6 is greater than or equal to 2. So I will decrement again out of it, and now it has become 4. So I will increment it by 1. Again, I know 4 is greater than or equals to 2. I will again decrement it. Now it has become 2. And again, I have increment that value by 1. Now again, I will see is 2 greater than or equals to 2. Yes, it is. It is equal to 2. So I will again decrement it, and I will just again increment the value of NC. So it will become 6. And as 0 is not greater than equals to 2, so I will move to the next index, that is 6. So I will see is 6 greater than or equals to 2? Yes, it is. So I will just decrement it, increment the value of NC. It will become 7. And 6 minus 2 is 4. Is 4 greater than or equals to 2? Yes, it is. So just decrement it. Now it has become 2. And as I have decremented the value, I will just increment it by 1. Now it has become 8. Is 2 greater than or equals to 2? Yes, it is. So I will decrement it and again increment the value by 1. So now it has become 9. Is 0 greater than or equals to 2? No, it is not. So I will just stop. Now I will see what is the value of my NC, that is 9. So is 9 greater than my K? Yes, it is. So yes, 2 can be my possible solution. It can be my possible solution. It is my solution or not. We will be checking. Okay. So now I know in this question the answer is 5. So now let's again do it by 5. I think we should be doing one more thing before it. So see, in this question we see that we are each time we are decrementing it by the value of the predicted value. So what if I see I am just decrementing it, and it is taking just log n time, and can I do it in a big O n time, big O one time, like in a constant time? I think yes, because If I just divide the 5 by 2, it will give me 2. And if I just divide the 8 by 2, it will give me 4. And it is the number of children, the number of children Candice getting from this index, that was 2 only. And in this case also it was 4 only. In this case, let's see, there's 1 children, 2 children, 3 children. If I divide the 6 by 2, it will be giving me 3 only. It means I don't need to decrement in such a way, just by doing by divide by subtracting it by 2 again and 2 again and 2. We can just divide it by the predicted value, and I will be getting that what is the number of children who can get the candies from that index. So I know it is 3. So 4 plus 2, 6, 6 plus 3, 9, and yeah, 9 was my solution. So in the next example, in the now let's take the value equals to 5. And this time I will not be decrementing it by the predicted value. I will just divide it. My question was 5, 8 and 6. So if I divide 5 by 5, it will give me 1. If I divide 8 by 8 by 5, it will give me 1. And if I divide 6 by 5, it will give me 1. So just add them up. 6 plus, sorry, 1 plus 1 plus 1, that is 3. So in this case, my NC will be equals to 3. Is 3 equals to or greater than K? Yes, it is. So yes, it can be also my possible solution, and I will be checking all the solution. Whatever will be maximum, I will say it is my final solution. So let's code this part first of all. I will make a function, boolean function, to check whether it is a possible solution or not. I will be taking that candies, both these values to check, and last one my predicted value. Okay. Now what I will be doing, I will take one integer, let's say NC, and I will be checking the whole candies array. And what I need to do is I will be incrementing the NC array by what? By num divided by predicted value. This is the same we were doing in that example. We need the sum of these quotients. So the same we are doing here. I am taking NC and I am doing the sum of all the quotients which I am getting from each index. So at last I will be checking if NC is greater than or equals to K, then I will be returning true. Otherwise, just return false. So till now, I have got the function to see whether a particular value is a solution or not, and it is in n time. So now let's see how I am going to predict the value. So till now, I have got a function which is taking n time, and I know that at last I need a solution which should take which should take a total n log n time. And my second step is taking n time, so I need a solution to predict the value in log n time. So in this question I will be using the binary search. How I will be using it, let's see. So we know in binary search we need a lower value and the higher value. My solution should be under this constraint only. My solution should remain either greater than equals to lower or lesser than equals to higher. How I'm going to see it range. How I'm going to find this range? See, if the solution doesn't exist, so my answer should be 0. It means my lower value should be 1. If it is 1, it means it does exist in my solution. Now let's come to the higher one. How I'm going to find what can be my highest possible solution? So in this question, it was 5. It was 5, it was not 6. So is it the thing that the smallest element in the array is my highest limit? Actually not, because if we will see this, array, then we can just see the smallest element is 1 and we need to give candies to 3 children. So if I will be taking the lowest value to 1, as I said, the lowest is 1 and highest in this case, let's say I'm taking the smallest value, that is 1 only. So 1 will be my solution if it is possible. But actually in this question, if we see, if I will be taking 3 candies from this index, 3 candies from the next index and 3 candies from the next index, so it is a possible solution and I can give these 3 candies to each of the children of length 3. So in this question 3 will be my solution, but we predicted the wrong value of the highest one. So after this example, we know that the smallest element is not our highest range. So what can be the our highest range? So let's do one thing. Let's take the highest, the maximum element, the maximum element of our array. So it was 8. So is my solution in this range always? 1 to 8. Yes, in this case it was 5. If we take this case, 1 to 5, is my solution was in this range? Yes. So it is not always like the highest element will be our solution, but the solution, whatever will be the solution, it will always be there in that range. It will be always, if it is possible, then it will be always in the range from 1 to the highest, the maximum element of the array. So now let's proceed. So let's do one thing. So I know my range is 1 to 8 in this question. So I will just 2, 3, 4, 5, 6, 7, and 8. This is my range. Now we know that binary search we used 2 pointers. First one will approach here. The second one will approach here. Now I need to find the middle element. So just count the indexes 0, 1, 2, 3, 4, 5, 6, 7. We know that in binary search we just find the mid by left plus right minus left divided by 2. We can also do it by left plus right divided by 2. But see, this approach has an issue because see, whenever the left has a value, for example, 10 raised to power 8, 10 raised to power 8, and right also has value 10 raised to power 8. So at that moment, and the limit of my integer is 10 raised to power 8 only. So in that moment, what will happen? It will be just exceeding the limit of my integer in this instance, and it will just give me an error. That is why what we do, we don't use this approach, we use this formula, that left plus right minus left divided by 2, because in this approach whatever the value of left is 10 raised to power 8 plus 10 raised to power 8 minus 10 raised to power 8 divided by 2. So it is never gonna happen that the value in this formula is exceeding my limitation of my integer value. So that is why this approach will never give me that exception that the integer is out of the limit. So that's why we will be using this approach. So yeah. So in this question, I'll just do one thing. First of all, let's give it the indexing. So see how is it working. We know it is 0 index, it is 1 index, it is 2 index, 3, 4, 5, 6, and 7. Sorry, 6 and 7. So I know the left value is 0 and the right value is 7. So my what will be my mid? Let's do one thing first of all. Let's take it this also. Uh-huh. Yeah. So my mid is, what is my mid? My mid is 7, sorry, 0 plus 7 minus 0 divided by 2. So what it will be? It will be 3. So my mid will be 3. Let's see, 0, 1, 2, 3. So I will check for 4, whether 4 is my possible solution or not. M- My function will see whether 4 is a possible solution. Yes, it is. So I will just store it. I will say this is my possible solution, that is 4. Okay. Now, after getting this, what I will do, I will move this pointer to whatever my possible solution is, plus 1. Now, what is my range? My new left is, my new left is 4 and my right is 7. Now, what will be my new mid? My new mid will be 4 plus 7 minus 4 divided by 2, which will be 4 plus 7, 7 minus 4 is 3. 3 divided by 2 is 1. So it will be 5. So my new mid will be 6. Is 6 a possible solution? No, we just checked that the 6 is not a possible solution. That is why we will not update my answer. And what we will do, if I am not getting my solution, I will just take this pointer and take it to whatever was the middle value minus 1. So I will just take it here. So what is my new value for left? My new value for left is 4. New value for right is also 4. So what will be my mid? That is 4 plus 4 minus 4 divided by 2. So what it will be? 4 plus 0, that is 4 only. So now I will be checking whether 5 is a possible solution or not. So we just added 5. 5 was our answer only. So yeah, it will give positive response and say yes, 5 can be a possible solution. So now just do one thing, update my answer to 5. Okay, I hope you got it. So now what I will be doing, my left will, we know that my left will move to the next pointer. What will be the next index? Now my condition was while the left is greater than equals to right. But now my left is at the fifth index, my right is at the fourth index. My right is getting smaller than the left. So that is why it will just come out of this loop and we will just return my answer. Okay, I hope you got it. So let's do one thing, let's code it out. So let's remove this. So we will be taking a variable answer. This is the answer which we will be returning at the last. Now, first of all, what I need? I just told you that we need maximum. We need the maximum element of an array. First of all, let's find that out. Just do one thing. We will say the maximum, initialize it with 0. and traverse the whole array. And just do one thing. Just see who is maximum, the num in the array or the maximum. So whatever will be the maximum element of the array, it will just come and be stored in this variable. Okay. Now what will be my left? My left, as I told earlier, it will be 1. What will be my right? Right will be the maximum element of my array. So it will be maximum. Now let's start our loop till the time my left is smaller than or equals to right. I will be traversing. Okay. And I will be finding my mid equals to left plus right minus left divided by 2. I just got my mid here. Now what I said, I will be checking whether it is a possible solution or not. Let's do one thing. Possible or not. So just check it is a possible or not. I will be passing candies. I will be passing the value of k, and my prediction is mid. Okay. So if it is possible, then do something, else do something. So what I told you, if it is possible, so just update my value of answer to mid. Okay. And just update my left to mid plus 1, which I told you that whenever I was getting the solution, my left was getting incremented by 1, by mid plus 1. And whenever it is not a possible solution, just do one thing, just put right equals to mid minus 1. So at last, just return the value of answer. So let's see whether it will be working or not, or there is any syntax issue. So yeah, the test cases are done. It is taking a bit of time. Okay. So there is an issue. So we will be seeing that. So yeah, actually the issue was that my NC was integer, but it should be a long value. Why long? Because the k can be, the k given is long. So if it is integer and it is getting out of the bound of integer, that is why it was giving the wrong answer. So let's see if it works now. So test case are done, and just see. So yeah, now the question is solved, the summation is done. It is beating 90% of the solutions. It means quite a decent solution. So thank you. That's the end of the